viewers. This is yet another day. We will continue with our class as we introduced ourselves the day or yesterday. We were learning on integration, and yesterday we learned two important subtopics. We learned on indefinite integrals and definite integrals. We also learned on how to determine the area under a curve. So in this session, I want us to emphasize more on area under a curve by doing one example. Then after we are done with that one example, we will proceed to applications of integration in kinematics. Tune in, ensure you have subscribed to my YouTube channel, turn on the notification bell, also like my video so that each and every time I upload a new video or each and every time I'm on air, you'll always be able to access my tutorials. So today we will continue with integration. I'll also take this opportunity to apologize. I had promised to start my class at 10 a.m. but due to some hiccups here and there, I had to start in this hour. Also, I had to manage the live streaming program to ensure that everything runs smoothly, so that in the course of the lesson, we will try as much as possible to avoid any distraction. So feel much welcome, and now we can start our lesson. So we will continue with area under a curve. Area under a curve. Area under a curve. So in our previous lesson, yesterday we did on area under a curve on curves that were already drawn for us, functions that were already drawn for us or plotted on a Cartesian plane. Now I want us to determine the area bounded under a curve from what we call a statemental problem or a word problem. And we can have an example as example number 1. Find the area enclosed by the curve. Find the area enclosed by the curve. Find the area enclosed by the curve y is equal to 3x squared plus 8x and the x-axis So we have such a question. We are supposed to determine the area enclosed by the curve y is equal to 3x squared plus 8x and the x-axis. So for us to be able to determine that area, which is bounded between the curve and the x-axis, we need to sketch our curve. So the first thing we are going to do in this question, we will do what we call curve sketching. We are going to sketch our curve, and once we sketch our curve, we will now be able to determine that area bounded under the line and under the curve, under the line x-axis and the curve y is equal to 3x squared plus 8x. So for us to sketch our curve, bearing in mind y is equal to 3x squared plus 8x, we are going to find the derivative of our function, that is dy over dx, and it will be 6x plus 8. That will be our derivative, 6x plus 8. So once we have that, we know for us to determine the turning point, we need to understand that dy over dx at turning point is equivalent to 0. So we have 6x plus 8 is equal to 0. We will take 8 to the other side of the equal sign and have 6x is equal to -8. So we will divide both sides by 6 and we will have our x as negative by 2 is 4, by 2 is 3. We will have negative 4 over 3, which can also be written as negative 4 over 3 can also be written as negative 1 and a third. X can be equal to negative 1 and a third. So having that, we can be able to determine y, and our y, having this as our x, will be 3 multiplied by negative 4 over 3 squared plus 8 multiplied by negative 4 over 3. So our y will be negative 4 over 3 squared is equal to negative 4 over 3 squared. This one squared is equal to 16 over 9. 16 over 9 multiplied by 3 is equal to 48 over 9 minus 8 times negative 4 is equal to 32 over 3. And we have our y as 48 over 9 minus 32 over 3. That will definitely give us negative 5 whole 1 over 3. So our turning point will be negative a third and negative 5 1 over 3. So having that, we will now determine the x and the y intercept, and our x-intercept, y is always equal to 0. Y is always equal to 0. So we will take our x, our y, we replace it with 0, and we will have 0 is equal to 3x squared plus 8x. 3x squared plus 8x. Having that, we will continue it here. And since our common factor is equal to x, we will say that x into brackets 3x plus 8 is equal to 0. X into bracket 3x plus 8 is equal to 0. We have factorized 3x squared plus 8x to get x into bracket 3x plus 8. Then we will proceed and say x is equal to 0, or 3x plus 8 is equal to 0. So when x is equal to 0, our other x will be equal to negative 8 over 3, which is equal to 2 and 2 thirds. Negative 2 and 2 thirds, that is equivalent to negative 8 over 3. And having that, we can be able to determine our y. So when our x is 0, our y definitely will be 0. Or when our x is negative 8 over 3, our y will be, so substitute the values of 8 over 3 or negative 8 over 3 into our equation, and we are going to get negative 8 over 3 squared is equal to negative 8 over 3 squared is equal to 64 over 9. 64 over 9 multiplied by 3 will be equal to 64 over 3. 64 over 9 multiplied by 3 will be equal to 64 over 3 minus 8 multiplied by negative 8 over 3 is equal to 64 over 3. So our y will be 0. So our coordinates for x-intercept will be 0, 0, and negative 2, 2 over 3, negative 2, 2 over 3, and 0. Those are the coordinates of the x-intercept. We can now proceed to determine the coordinates on the y-intercept. on the y-intercept, and our coordinates in the y-intercept, we know that x is always equal to 0. So if our x is equal to 0, then when we substitute the value of x on our equation here, we will still get y as 0. So the coordinates for y-intercept is equal to 0, 0. So having the turning point, the x-intercept and the y-intercept, we can now proceed to sketch our curve. And when we sketch our curve, we are going to get, let's sketch our curve over this area. And let me first explain on why we are sketching the curve. The reason we are sketching the curve is because from our original question, the curve has not been drawn for us. So we must first interpret the shape of the curve. We must first see how the curves look like so that we can figure out that area enclosed by the curve and the line. We figure out where that area is. So that is why it was necessary for us to sketch the curve. Then, curve sketching, we did it under differentiation. That is why we have first determined the turning point. And after determining our turning point, we have emphasized also on finding the x-intercept and the y-intercept so that we can be able to sketch our curve accurately. So let's sketch out our curve. So we have the x-intercept as 0, 0. The y-intercept is still 0, 0. We have another x-intercept, negative 2 and 2/3. So it can be here, negative 2 and 2/3. And the next one is the turning point, negative 1 and a third, negative 1 and a third. And the y is negative 5 and a third. Y is negative 5 and a third. So let's sketch our curve. We will start with our turning point. Our turning point is equal to negative 5 and a third, negative 1 and a third, negative 5 and a third. So our turning point will be around that area. Our x-intercept will be negative 2 and 2/3, 0. And the other x-intercept is 0, 0. And our y-intercept is 0, 0. Therefore, the shape of our curve, negative 2 and 2/3. The shape of our curve will be like this. It will be like that. That will be the shape of our curve. And by having our curve as that, y is equal to 3x squared plus 8x, we can therefore be able to determine the area enclosed by the curve and the x-axis. The area enclosed by the curve and the x-axis. And that area is none other than this one. So that is the area enclosed under the curve and the x-axis. And for us to determine that area, we are going to integrate. Our integral boundaries will be between negative 2 and 2/3, which is equal to negative 8/3 up to 0. And we are integrating 3x squared plus 8x with respect to x. We are integrating 3x squared plus 8x, our function, with respect to x. Why with respect to x? Because x is the dependent variable. So the reason we have drawn this is so that we may be able to determine the integral boundaries in which we are integrating our function from and to. So we will now continue integrating this. Remember how we integrated yesterday. So this first one is going to be 3/3 x cubic plus 8/2 x squared plus c. from negative 8 over 3 to 0. From negative 8.3 to 0. So let's utilize this space. So 3 divided by 3 is equal to x cubic plus 4x squared plus c 0 negative 8 over 3. So we are going to take the first we equate with 0, then we subtract negative 8 over 3. So it's going to be 0 cubic. So when we substitute 0 to everything here, it will be 0. So it will be c. It will be 0 plus c minus, we substitute the second one, negative 8 cubic negative 8 cubic, negative 8 over 3 cubic plus 4 negative 8 over 3 squared plus c, and by doing that we will have c minus negative 8 over 3 cubic, negative 8 over 3 cubic, negative 8 over 3 cubic is equal to negative 512 over 27 plus negative 8 over 3 squared is equal to 64 over 9. So 64 over 9 multiplied by 4, we will have 256 over 9 plus c. And our final solution will be negative 512 over 27 plus 256 over 9. That will give us 256 over 27 plus c. Once we open these brackets, we have c minus 256 over 27 minus c. So c minus c is 0, and we will be left with negative 256 over 27 stroke, we can write it as a mixed number, negative 913 over 27. So remember, in our previous lesson yesterday we said that when we find our area is negative, it simply means that the area is bounded under the x-axis. And if you check this one clearly, you will see that this area is under the x-axis, and having that area under the x-axis, that is why we are getting a negative area. So when you get a negative area, no need to worry. It simply means that the area is under the x-axis, and what we are going to do is we are going to omit the negative and take our area as 913 over 27 square units. We will take our area as 913 over 27 square units. So that will be our area. So I would plead with you to do more and more examples on area under a curve and see how we go about it. You see, it's not something hard. Once you are conversant with definite integrals, be assured that it's very, very easy to maneuver through determining the area under the curves and under the lines. Another important thing I would like to mention concerning area under curves or area using integration is that area determined through integration is always accurate. It is always accurate. The area determined under integration is always accurate. If you use formulaic methods to determine area and use integration to determine areas, be assured that you will be able to determine accurate area. So we have now come to the end of area under a curve. I want us to proceed and determine the applications of integration in kinematics, or how do we apply integration in calculating velocity, acceleration, and displacement of objects and bodies. So that is what we are going to continue in our next subtopic. So let's check out on what we have today. So this is our next subtopic, and it is also the last discussion we will have under integration. Once we are done with application of integration in kinematics, we will be done with that topic. Don't forget that this topic is very, very applicable. It is highly examinable in the national examination KCSE paper 2. So paper 2 assesses integration, while paper 1 assesses differentiation. So this is very, very important. Whatever we are doing, whatever we did yesterday, the day before yesterday, and today is very, very important. So we will now proceed to how do we apply the knowledge of integration in kinematics, and we have simply defined kinematics as calculation of acceleration, velocity, and displacement on anything that involves motion of bodies. So that is what we will be discussing in this lesson. So we might have our first example. Given the velocity of a moving particle, given the velocity of a moving particle as v is equal to 3 plus 2t, 3 plus 2t minus 4t squared, minus 4t squared, comma, find the distance, covered, find the distance covered from t is equal to 0 to t is equal to 8. Find, given the velocity of a moving particle as v is equal to 3 plus 2t minus 4t squared, find the distance covered from t is equal to 0 to t is equal to 8. So let me start off this particular subtopic from this perspective. In differentiation, we say that given the displacement, velocity, and acceleration, we say that given the equation of displacement, we differentiate, we find dy over dx or ds over dt in this case to get velocity. Then, given velocity, we find dv over dt to get acceleration. This is differentiation. By this, we are differentiating, moving from displacement to velocity to acceleration. But now, in our question, we have been given the equation for velocity, and we are supposed to determine the displacement or the distance. So, given the velocity, to determine the displacement, what we do is that we integrate. So in this case, we will integrate. That's why we called this topic reverse differentiation. We will integrate velocity with respect to time to get displacement. For us to get velocity given acceleration, we integrate acceleration with respect to time to get velocity. I hope you have understood. I hope I'm clear. Given displacement asked to determine the velocity, we differentiate. Given velocity to determine the acceleration, we differentiate. But now we are reversing. We have been given the equation for velocity, and we are now supposed to determine the distance from 0 to 8. So these two are our integral boundaries. So for us to determine the distance or the displacement given the velocity, we are supposed to integrate velocity with respect to time so that we can get the distance. I hope I'm clear. I hope you have understood. So for us to determine the distance, between 0 to 8, we are going to integrate from 0 to 8. We will integrate velocity with respect to time. We will integrate velocity with respect to time, that is t, and our integral boundaries are between t is 0 and t is 8. And once we determine this, we will have already determined the displacement of the distance. So we will continue and say that when we integrate 3, it will be equal to 3t plus, when we integrate this, it will be equal to t squared, because it will be 2 over 2t squared. 2 cancels with 2, then this one will be equal to minus 4 over 3t cubic. In this case, it is not a must we add the constant, because even if we add our constant, it will eventually be calculated. So let's just use our integral as it is. So we will now substitute the values. 3 multiplied by 8 plus 8 squared minus 4 over 3 8 cubic minus, when we substitute all this, it will give us 0. 3 times 0 is 0, plus 0 squared is 0, 0 cubic is 0, so everything is 0. There is no need of writing that. I know we are quite conversant with it already. So we will now proceed and get 3 times 8 is 24. 24 plus 64 minus, so 8 cubic is 512 multiplied by 4 over 3 is equal to 2048 over 3. So it will be minus 2048 over 3 minus 0. So we will work this one out and we will get 24 plus 64 minus 2048 over 3. Sorry. So 24 plus 64, 8 cubic is 512 multiplied by negative 4 over 3 is equal to negative 2048 over 3. Then once we work that one out, 24 plus 64 minus 2048 divided by 3, we will get our displacement as negative 594, 203. So that will be our displacement. Remember, when we get a negative displacement, it simply means that the object was 594, 2/3 meters behind where it was initially supposed to start. So we are going to have 594, 203 meters. So that is our displacement. So after determining that will be our first example. So for us to get displacement, we integrate velocity with respect to time. For us to get velocity, we integrate acceleration with respect to time. Don't forget that. So let's get to our second example. So example 2. The initial velocity of a particle is given as 9t squared plus 3 meters per second. Find the distance covered by the particle during the 4th second. During the 4th second. During the 4th second. Find the distance covered by the particle during the 4th second. So we are going to determine that one, and we have been given the equation for velocity. The initial velocity of a particle is given as 90 squared plus 3, and we are supposed to determine the distance during the 4th second. We are supposed to determine the distance during the 4th second, and this is how we are going to go about it. We are going to take the equation for velocity. Velocity is equal to 9t squared plus 3. That is the equation for velocity. So having the equation for velocity, we are going to determine the equation for displacement. And for us to determine the equation for displacement, we need to integrate velocity with respect to time. But we have been told to determine the distance covered during the 4th second. So we need to interpret and understand where is the 4th second. So the 4th second, remember, from 0 to 1, between t is 0 and t is 1, that is where the 1st second lies. Between 1 to 2, or when t is 1 and t is 2, that is where the 2nd second lies. Then between t is 2 and t is 3, that is where the 3rd second lies. And between t is 3 and t is 4, that is where the 4th second lies. So what we need to understand is that we are determining the distance covered during the 4th second, not when t is 4, not when time is 4 seconds. It is during the 4th second, and the 4th second is between t is 3 and t is 4. So it is between t is 3 and t is 4. So for us to determine that integral, that distance, we are going to integrate from the lower boundary 3 to upper boundary 4, and we will integrate 9t squared plus 3 with respect to t. And by solving this one, we will now be in a position to get the distance covered by the particle during the 4th second. So once we integrate 9t squared, we are going to get 3t cubic. I hope you now understand where it's coming from. It's 9 over 2 plus 1 is 3. So 9 divided by 3 is 3. T, then the power, we had 1, plus 3t. Then we have 3 and 4. The reason I have not added the constant is because at the end of it all, the constant will be terminated. So we will have 3 into brackets 4, sorry, so we have 4 cubic plus 3 times 4 minus 3 cubic plus 3 multiplied by 3. And by having that, 4 cubic is 64. 64 multiplied by 3 is equal to 192 plus 3 times 4 is 12 minus 3 cubic is 27. 27 times 3 is 81. Then 3 times 3 is 9. So our distance will be 192 plus 12. It will be 204 minus 81 plus 9 is 90. So 204 minus 90 will give us 114 meters. It will give us 114 meters. So that is how we determine the distance covered during the 4 seconds. So we will continue with another example. So you have example 3. A particle moving in a straight line starts at a fixed point. It starts at a fixed point or with a velocity of 20 meters per second. After 3 seconds, its acceleration a meter per second squared is given by a is equal to 5 minus vt. Find a velocity, find its velocity at t is 3. Find its velocity at t is 3. Then b, the distance covered when the particle first comes to rest. First comes to rest. So in this question, we are going to do our solution in this part. So let's do our solution here. And we will start with A. And we are told a particle moving in a straight line starts at fixed point O with a velocity of 20 meters per second. So the initial velocity is 20 meters per second. After t seconds, its acceleration a meter per second squared is given by a is equal to 5 minus 3t. So we are going to take our acceleration as 5 minus 3t, and having that as our acceleration, having that as our acceleration, 5 minus 3t, for us to get velocity, the equation for velocity, we will integrate acceleration with respect to time. So for us to get velocity, we will integrate acceleration with respect to time. So once we integrate acceleration with respect to time, we will get velocity. So velocity is equal to 5t minus, this one will be equal to 3 over 2t squared plus c. Why have we introduced a constant? We have introduced a constant because this one is an indefinite integral. We don't have integral boundaries. But since we have been told that the initial velocity is 20 meters per second, we are going to substitute our constant with 20. Why? Because constant is initial, it is not changing. So we will have velocity equation as 5t, or instead we can start with the constant and say it will be 20 plus 5t minus 3 over 2t squared. That will be the equation for velocity. We have added the initial velocity because we have already been told it is the initial or the starting velocity, and we have added it to this particular point of a constant. So that is the equation for velocity. So for us to find velocity when t is 3, we already have the equation for velocity. Velocity is 20 plus 5t minus 3 over 2t squared. We are supposed to find the velocity when t is 3. So for us to determine velocity when time is 3, we will substitute our value of t to our expression, and once we do that, we will get 20 plus 5 multiplied by 3 minus 3 over 2, 3 squared, and by doing that, we will have velocity as 20 plus 5 times 3 is equal to 15. Then 3 squared is 9. 9 times 3 is 27. That will be 27 over 2. So our velocity will be equal to 20 plus 5 is 35. 35 minus 27 over 2 will be equal to 21 and a half. It will be equal to 21 and a half meters per second stroke 21.5 meters per second. That will be our velocity when time is 3 seconds, or when t is equal to 3. Let's proceed with our second equation, or our second question. And our second question is simply stating that we find the distance covered when the particle first comes to rest. So we need to understand that at rest, when the particle comes to rest, velocity is always equal to 0. Because we say an object or a body is said to be momentarily at rest when velocity is 0. So what we are going to do, we will take our equation for velocity. Velocity is equal to 20 plus 5t minus 3t, 3 over 2t squared. That is the equation for velocity. And since at rest velocity is 0, we will substitute this equation with 0, and we will have 20 plus 5t minus 3 over 2t squared is equal to 0. Is equal to 0. Why are we equating it to 0? So that we can be able to determine the time or the value of t when the particle is at rest. And once we do that, to eliminate this denominator, we can multiply both sides by 2. And when we multiply by 2, we'll have 40 plus 10t minus 3t squared is equal to 0. 40 plus 10t minus 3t squared is equal to 0. So having this is a quadratic equation, and when we have this as a quadratic equation, we can ensure we make our first, the highest degree, we make it positive, we make the coefficient positive, so we can divide by negative 1, by negative 1, by negative 1, by negative 1. And once we do that, we can start by writing this one. We will have 3t squared, then this one will be minus 10t minus 40 is equal to 0. At least when a quadratic equation is written in this manner, it's easier for us to be able to solve and determine the value of x. So by having that, we can now continue and determine the value of t. So this one is a quadratic equation. We can use quadratic factorization. We can also use quadratic formula method. We can also use completing square method to determine the value of t in this equation. And we are going to do it right away. We will use quadratic formula. So let's use quadratic formula method. Quadratic formula. And quadratic formula simply states that t is equal to minus b plus or minus b squared minus 4ac over 2a. Minus b plus or minus b squared minus 4ac over 2a. So having that as our formula, our a is 3, our b is negative 10, and our c is negative 40. So we can be able to determine our value of t. So let's do it on this place here. So we will say t, sorry. So we will say t is equal to minus b will be minus 10. It will be 10 plus or minus. We have the square root side. B squared is negative 10 squared minus 4ac. A times c is 3 times negative 40. It will be negative 120 over 2a. 2 times 3 is equal to 6. So our t will be equal to, our t will be equal to 10 plus or minus negative 10 squared is equivalent to 100. Then minus 4 times minus 120 is equivalent to 480 over 6 over 6 over 6 over 6. And having that, we have 10 plus or minus square root of 100 plus 480 is equal to 580 over 6. And we'll have our time as 10 plus or minus the square root of 580 is 24.08 over 6. So our time will be equal to 10 plus 24.08 is 34.08 divided by 6. We have our time as 5.68 seconds. Then we will omit 10 minus 24 because it will give us a negative time. And we all know that negative time is unrealistic. So we will now proceed to find the displacement. The question was asking the distance covered when the particle first comes to rest. Why did we first find t? Is because we know at rest velocity is 0. So we had to determine the value of t when the particle coming to rest, and we have determined our t as 5.6 feet. So we will now determine our displacement, and for us to determine distance, we need to integrate velocity. Where is velocity? We need to integrate this function 20 plus 5t minus b over 2t squared. We need to integrate it with respect to t so that we can get displacement. So we integrate this function to get displacement. And once we integrate it, we will get 20t plus, once we integrate this, we will get 5 over 2t squared. And once we integrate negative 3 over 2, we are going to get minus a half t cubic. So that will be the equation for velocity, for displacement. And we are supposed to determine the distance when t is 5.68. So it is from 0 to 5.68. That is what we are supposed to determine. So we will substitute our values, and we will get 20 multiplied by 5.68 plus 5 over 2 multiplied by 5.68 squared minus a half multiplied by 5.68 cubic. All that we subtract 0. Why are we subtracting 0? Once we substitute the values of zeros on our expression, it will all bear 0. So that's why we are putting down as 0. And by doing that, we are going to have 20 multiplied by 5.68. We have 113.6 plus 5.68 squared multiplied by 5 over 2, we have 80.656. Then 5.68 cubic multiplied by a half, we we have minus 91.63 minus 0, and by solving that we have 113.6 plus 80.656.6 meters. So that is the displacement or the distance covered when the particle came to rest at first. So I think by doing those few examples we have done, we are now conversant with integration and how integration is applied in calculating velocity and acceleration. So we have come to the end of our session. I don't know why the screen is misbehaving, but I'll check out from my side and see what the problem is. But at least I'm happy that we have been able to follow up. We have been able to understand whatever we had intended to do. We have come to the end of our topic. In our next lesson, I intend to now deal with section 2 questions because most of the students have challenges in section 2 questions in which I really want to address in. But before we end up or wind up our lesson, I would encourage you to subscribe to my YouTube channel. Ensure you turn on your notification bell so that each and every time I upload a new video, you always be updated. And I promise to help you become the best, to be the best mathematician that ever is, and to realize your passion and potential in mathematics. Have a good day, have a blessed day. I'll still upload more videos today. I'll be doing also short structured questions and guiding you on how to choose questions, and I also guide you on how to make how to make yourself productive in maths and how to make yourself fall in love with maths. Maths is easy. Maths is very, very easy. It's easy to maneuver it, and I believe that in these tutorials that I'll be teaching, you will become the best. Another update I want to update concerning the college and university students. I've not forgotten you. I'm still making plans and arrangements on how to assist you in different concepts of mathematics. College and university maths, that is advanced mathematics. I'll work out on that, and I'll come up with a whole schedule on how to approach it and make it more simple to you. Thank you so much. Have a blessed day. Thank you.